Okay, so what I want to do now is finish section P5 today, which is dealing with rational expressions. I did email everyone the notes. Okay, so you should have it. Okay, let me see something actually. Let me just 1 second. Let me just see if that affects anything. No, everyone can see it. Okay, good. Okay, so now I want to keep going. So this slide again here. Wait, let me show you can hear me. You know, on this slide, basically, it's just sort of a refresher, so to say, or a recall. You know, when you add rational expressions, you know, just like you add fractions of integers, the denominators have to be the same. They have to. Okay. You know, that's just how you add fractions of integers. Fractions of integers, okay? The denominators must be the same. And basically, to get the common denominator, for us, it's going to be the least common denominator, mostly because when you simplify in the end, you'll have the least amount of work to do if you have the least common denominator. That's what our common denominator is going to be, even though theoretically you can use any common denominator you want. Now, and here, this is how we manipulate so the denominators are the same. You know, whatever we're missing, right? Whatever we're missing to get the LCD, whatever factor we're missing, we multiply the denominator by it. And whatever you do to the bottom, you have to do to the top. That's what this is reminding you. You have to keep everything algebraically equivalent. Then, once the denominators are the same, you only add or subtract the numerators. And you know, the denominators, of course, you leave alone. Also here, it probably goes without saying, B and C are non-zero. So that kind of goes without saying, I guess, but felt better saying it anyway. Okay? So this is just a refresher. That is, this slide. So let me just do this. So let's do this example. Suppose we have this. We're adding these two together. Well, notice the denominators here, they are not the same. And because they're not the same, we have to get a common denominator. Now, you can see these denominators, they're already factored. Okay, so let's list them. We have x minus 1, 3x plus 2, right? And notice that their exponent, their greatest exponent, actually their only exponent's 1. I mean, you get among the denominators here, right? The only exponent of each factor is 1. So because of that, the greatest exponent's 1, and so because of that, the LCD is just this. Right? We have x minus 1 to the first times 3x plus 2 to the first. And that's just equal to this. Okay. Now, we have to manipulate each of these expressions, right? So that the denominators are the same. So for the first one, we want the denominator to be this, right? The LCD. So what are we missing? Well, we're missing x minus 1. X minus 1. And so, because of that, right, we have to multiply the denominator by that. But remember, whatever you do to the bottom, whatever you do to the bottom, you have to do to the top, right? You're multiplying the bottom by something, the denominator. You have to multiply the numerator by it as well. That's what we're doing here. And so from here, right, we're going to get 3x plus 2 times x minus 1 on the bottom, and we just get x minus 1 on top. You know, x minus 1 times 1, we get that on top. Down here, for the second expression, 3 minus x over x minus 1, right? So here, we're going to have 3 minus x over x minus 1. But again, we're missing the 3x plus 2, right? That's what we're missing. So we're going to multiply the bottom by that. We're also going to multiply the top by that, as you can see. Okay, now from here, what we're going to get is this. Right? The bottom we multiply by 3x plus 2. The top we multiply by 3x plus 2 as well. And this is what we get. Okay. Now, notice also, actually, let me say this. The denominators we're actually going to leave in factored form because, again, we want to simplify. And to simplify, you want the denominators factored. So I know it's tempting to FOIL the denominators, but we're not going to do that. Instead, as you can see here, we're going to add the numerators together and FOIL the top. So here, we're going to FOIL, that is, we're going to multiply 3 minus x with 3x plus 2. And when you FOIL this product, that is, you know, you multiply, we get this. And so we now combine like terms. Namely, we're going to have x plus 9x minus 2x. And that becomes 8x. We have minus 1 plus 6, that's just 5, minus 3x squared as well. So after all this, we end up with this here. Now, are we done? Not quite, right? Again, we want to simplify. Now, we could and basically to simplify, what are we trying to determine? Does the numerator and denominator have any non-trivial common factors? In other words, we want to know, is x minus 1 a factor of the numerator? And is 3x plus 2 a factor of the numerator? So we want to know if it's simplified. Well, we could factor the numerator. You could try factoring that. I'm not sure how easy it is to do. I didn't try it, to be honest. But what's nice is it doesn't matter because we have the factor theorem. And from the factor theorem and what I wrote over here, right, for x minus 1, it's enough to determine if 1 is a root of the numerator, if the numerator maps 1 to 0. For the other factor, notice what I did was I rewrote it as this, mostly to apply the factor theorem. The coefficient of x here, okay, we need that to be 1 if we're going to use the factor theorem. So what I do here is I factor out 3, right? That's what I did. You know, when you factor out, you divide to get what's left over. And it also has to be minus here, not addition. That's why we do this. I'm just using the factor theorem. That's all I'm doing. So by the factor theorem, for this factor, it's enough to see, will the numerator have negative 2/3 as a root. So what I said here was, well, let's let capital F of x be the numerator. By the factor theorem, it suffices, it's enough to check, is f of 1 0 and is f of negative 2/3 0? Okay, well, f of negative 2/3, you just plug it into the numerator. That is, you plug it in for x. Capital F, remember, f of x, that is the numerator. We get this, as you can see. Right? And what do we get? We get negative 3 times negative 2/3 squared. Right? That's negative 3 times 4/9. Plus 8 times negative 2/3, which is this. Minus 16/3 plus 5. Now, really, you could actually stop here and I guess use your calculator. I went an extra step to get a common denominator. The main point is we want to know, is all this equal to 0 or not? And it turns out it isn't, as you can see. I mean, since it's not 0, that tells us 3x plus 2 here, this is not a factor of the numerator. That's what this is telling us. Right? So again, since f of negative 2/3 is not 0, so this does not happen, that's how we know this here, 3x plus 2, which is this, is not a factor of the numerator. With f of 1, same idea. We've replaced x by 1. Calculation's a little bit easier. You end up getting 10, which is not 0. Not 0. And because it's not 0, x minus 1 is not a factor of the numerator. So the numerator and denominator have no common factors. Excuse me, no non-trivial ones. So because of that, it's simplified. Are there any questions about this?